This is an advanced radar system. It can search for and target objects and identify them in great detail. How does it work? Let's break it down. The first step is searching. The radar system sends out electromagnetic waves to see if anything is out there. These waves travel at the speed of light, and when they hit an object, some of them get reflected back. The reflected waves are then picked up by the radar system's receiver. Now we have a signal, but it's just a blip on the radar screen and it doesn't tell us much. To get more information, we need to move the radar antenna to form what's called a radar beam. This allows us to pinpoint the location of the object and determine its range and bearing, but that still isn't enough information to identify the object. For that, we need to use a technique called synthetic aperture radar, or SAR. SAR works by moving the radar antenna in a circular motion. This creates a synthetic aperture, hence the name synthetic aperture radar. The larger the aperture, the more detailed the image. As the antenna moves, it takes a series of measurements and records the strength and phase of the returned signal at each point. The phase of the signal is how out of sync it is with the transmitted signal. Using these measurements, the radar system can create a map of the object's surface. But this is still just a basic radar image. To get more information, we need to move the antenna back and forth in a linear fashion. This creates what's called a radar line, a swath of data that contains information about the object's surface. By analyzing the radar lines, we can get information about the object's size, shape, orientation, and even material. This is because the way an object reflects radar waves depends on its properties. A large object will reflect more energy than a small object. A flat surface will reflect more energy than a rough surface. And the orientation of the object will affect the strength and phase of the returned signal. With enough data, we can create a detailed 3D model of the object. This can be used to identify the object and track its movements over time. But that still hasn't told us anything about the object's composition. For that, we need to use a technique called inverse synthetic aperture radar, or ISAR. ISAR works by taking the radar line and deconvolving it. This removes the effects of the radar system and the object's movement, leaving only information about the object's intrinsic properties. By analyzing this data, we can get information about the object's material, density, and even chemical makeup. So that's how this advanced radar system works. By using a combination of different techniques, it can search for, target, and identify objects in great detail. This technology has a wide range of applications, from military to civilian. It's used in everything from missile defense systems to weather radars to medical imaging machines. If you like optimistic science and tech stories, stay tuned for more.